This simulation models the relativistic kinematics of a stationary Higgs boson decaying into two collinear, massless photons and visualizes how fundamental conservation laws remain invariant across different Lorentz reference frames. In the rest frame, the two photons propagate in opposite directions with equal energy and momentum. However, when viewed by an observer in motion, a Lorentz transformation causes the forward-moving photon to gain energy and momentum through relativistic Doppler blue shifting, while the backward-moving photon simultaneously loses energy and momentum via red shifting. While the spacetime diagram dynamically tracks the ongoing physical propagation of the photons along invariant 45-degree light cones over time, the energy-momentum space maps the conserved state vectors. Within any single reference frame, these component vectors remain completely static over time, but adjusting the observer's velocity instantly glides the total system state point along a perfectly stable green hyperbolic mass shell boundary. This side-by-side geometric coordination elegantly demonstrates that even though frame-dependent energy and momentum values fluctuate wildly depending on the observer's speed, their vector summation perfectly balances to preserve total system conservation and keep the net invariant mass of the closed physical system constant.